Hi, Dr. Stewart. So this is a video just made to walk you through my package and what it does. And so to do this, I'm just going to go through the package vignette that I've created. And so you'll notice there are three main functions in my package, and they are generate samples, my numeric, and xbar. All of these functions are going to be used for the purposes of quality control analysis. And so you see the first function here is generate samples. Now this is going to be useful if you have a manufacturing process where you have thousands and thousands of items being produced weekly or monthly, and you want to select just a few for a quality control analysis. So what this function will do is it will take in your input data, it will take in a number of partitions you'd like to make to your data, and then a number to sample from each. So for example, you could put in input data with 1,000 observations and then partition it 10 times and then take 10 from each partition. So this will divide your data into increments of 100 and then take 10 from each 100 and then create numeric statistics and output those samples. Now this is going to be useful because you don't want to just take a certain number of random samples. You want random samples of data points that are at least close together. So that's why we partition first and then sample. And so this is an example of the function being run. You can see the show samples equals true option is specified, which means it's going to output what the actual samples are. So these are the data points that were used, and these are the means that were constructed, medians, etc. And so now this data could be used to feed into later quality control analysis. So like I said, we can probably use that aggregated data for future analysis, but here to keep it simple, we're going to use the same simulated raw data and use my new function, myNumeric, which will just create numeric quality control output from the input data. So the cool thing about this function is you can specify cutoff values, which will lead you to reject the fact that your output is adequate. And so here we say, if there's at least one outside of 2 standard deviations or 3 outside of 3 standard deviations, we will reject this batch. And so here we can see that there's only one outside 2 and one outside 3. Now these don't exceed these numbers, so we get our pass result here. Now we can make this far more advanced in the future, but it's cool that we can have an automated decision rule here that will return results. And then here it's kind of cut off in this vignette builder. I wasn't able to get this corrected, but here we see this output of the quality control plot. We see both the means and then the confidence limits for the means, as well as standard deviation limits, 2 standard deviations up to 3 standard deviations. Here, the other interesting thing with this function is we can specify regress equals true, which will fit a regression line to the new data, which is in blue here, and then print out a p-value for the significance of the beta 1 value in that regression line. Here we intentionally created this data with this plus 0.02 times 1 to 40, so we do get increasing data, but however this p-value isn't at all significant. So we failed to reject the null hypothesis that there's no linear relationship going on here. And so this is my package. I've linked this video in the vignette, but feel free to take a look and run the functions yourself in RStudio. Thanks so much for your time.